Okay. Config T interface fast Ethernet 0/0 IPv6 address. This is how we configure, we assign IPv6 address on the interfaces of router. IPv6 address 192.168:10, let's say :1/64. I'm using this IP address on router number 1, and I will use :2 on router number 2. Fine. How to verify IPv6 configuration? So IPv6 interface brief, exclude and assign. So you can see we have this IPv6 address on fast Ethernet 0/0, and this is link local address. This interface is administratively down, so let me run nosert command as well. Interface fast Ethernet 0/0, say nosert. Done. Now on router number 2, let me assign one IPv6 address on fast Ethernet 0/0, nosert, and IPv6 address 192.168:10:2/64. Okay, so IPv6 interface brief, exclude and assign. So we have this IPv6 address on fast Ethernet 0/0. Let me check connectivity from R1. Let me ping R2 192.168:10:2. Yes, so you can see there is reachability. Now we can configure BGP between router 1 and router 2. So what AS number you want to configure? iBGP, eBGP, which type of BGP neighbors if you want to configure, you can configure. Let's say I'm going to configure iBGP neighbors, BGP AS number 100 on both router. So on R1, first of all, before running any routing protocol for IPv6, you have to enable IPv6 routing. By default on router, IPv4 routing is enabled and IPv6 routing is disabled. So you need to run this command, IPv6 unicast routing, on both router, on R1 also and on R2 also. IPv6 unicast routing. This command will enable IPv6 routing on router. Fine. After running this command, same I will run router BGP AS number 100, and then neighbor IP address. See, router 1 need one IPv4 address for router ID selection. For router ID selection, BGP could not pick a router ID because we don't have any IPv4 address on this router. So manually here we have to define router ID, BGP router ID, BGP router ID, let's say 1.1.1. Fine. So IP protocol, so router ID. Okay, let me advertise interface in BGP. So router BGP is number 100, and say neighbor, who is neighbor 192.168:10:2, and remote AS of neighbor is 100. Okay, and guys, with the help of this command, neighborship will not come up. See, on router number 2 also I am going to run this command, router BGP AS number 100, and BGP router ID 2.2.2 and neighbor 192.168:10:2 and remote AS 100. Can't configure the local AS number. Oh, IP address is 1. Fine, but BGP neighborship will not come up. For IPv6 you have to activate neighbor manually. You have to activate neighbor manually. And how we will activate neighbor manually? With the help of address family. With the help of address family we will activate IPv6 neighbor. So on both router, on R1 you have to activate neighbor, and on R2 also you have to activate neighbor. So address family, I am going to configure I'm going to activate neighbor for IPv6. So address family IPv6, and then neighbor 192.168 colon 10 double colon 2 activate. On router number 2 also address family IPv6 and neighbor 192 colon 168 colon 10 double colon 1 activate. Now BGP neighbor C will come up. Okay, so this is neighbor of router 2. So IP BGP summary, we are not able to see any neighborship because this command is for IPv4 neighbor. This is for IPv4 neighbor, and whatever command you want to run for IPv4 you don't need to define it in address family, but for any other protocols you have to define it in address family first. So here what command I can run? IPv6 BGP so BGP, then IPv6 neighbor, IPv4 neighbor, IPv6 unicast neighbor summary. This is how we will check IPv6 BGP neighbor. So BGP IPv6 unicast summary, right? And now let's say router 1 is connected with one LAN interface loopback 1 IPv6 address, let's say 10 double colon 1 slash 128. Okay, now I need to advertise this network in BGP. So router BGP is number 100. Here if I will run network command, so that network command is for IPv4 not IPv6. So first I have to define IPv6 in address family, like IP address family IPv6 unicast, and then we can run network 10 double colon 1 mask, sorry, slash 128, and so IPv6.
It's 10, right?
Hmm?
You
I
given
think
us 100.
100 you defined.
Yeah, sorry. Router BGP is number 100, address family IPv6 unicast, and say no network 100 double colon 100 double colon 1 slash 128 network 10 double colon slash 128, right? So BGP IPv6 unicast and so IPv6
Unicast.
unicast.
Summary.
I want
You
to
gave.
check BGP table. It have not installed any prefix in BGP table, right? So run
Neighbor you can.
wait. Okay. Router BGP 100 address family IPv6 unicast and say no network 10 double colon and say network 10 double colon 1/128. So BGP IPv6 unicast. Now you can see BGP table. Router 1 have install this prefix in their BGP table. So router 1 will advertise it with their neighbor also. So on router number 2, so BGP IPv6 unicast. So router 2 have also learned this network, right? And this is next hop IP address. This is how you can configure, you can implement BGP in IPv6 network. Any question? Actually, when we are running this command, router BGP is number 100 and then network command. If we are running network command here, that means we are running address family IPv4 unicast. Here we are running actually network command. So for IPv4 you can ignore address family, right? Automatically it will take all commands for IPv4. Exit. One command is so BGP IPv6 unicast summary to check neighbor, and to check IPv6 BGP table you will run command so BGP IPv6 unicast. Router, let's say here also we have one LAN interface loopback 1 IPv6 address 20 double colon 1/128 and router BGP is number 100 address family IPv6 unicast and say network 20 double colon 1/128. So BGP IPv6 unicast, right? And on router number 1 also you can see router 1 have also received this network information. And now ping 20 double colon 1 source 10 double colon 1. Ping is also working. Okay. Can I move, guys?
So the double colon, actually, what it will represent?
We represent IPv6 address in
No. Yes, that is IPv6. But if we, for normally that IPv4, we are defining like 20.1.1.0
yeah,
something.
we separate each field with dot in IPv4, but in
Yes.
IPv6 we separate each field with colon.
Okay. But it should be 128 bits, right? Actually, how it will take?
Yes, length of IPv6 address is 128 bit. So if I am saying 10 double colon 1/20 128, so between double colon all bits are 0.
Okay. Uh-huh. Means 64 means /64 you represent.
Means network bits is 64 here. 128 means network bits are 128. Like IPv4 IP address is combination of host bit and network bits. IPv6
Yes.
are also combination of network bits and host bits. So I have created loopback, that's why I have defined IP address with /128. Like we can configure IPv4 with /32 on loopback.
Okay, means /64 means half of the bits are network and half of the bits are host.
Correct.
Okay.
And /128 means all bits are network bit.
Okay.
And we represent IPv6 address in hexadecimal. We represent IPv4 in
Yes.
decimal.
Yes. Yeah.
Okay, so let me do one thing again. Let me configure IPv4 address, turn off the device, turn on the device, and again here I am going to use 12.1.1.0/24 network. Now BGP states. How many states are there in BGP? How many states are there in OSPF? Neighborship state.
7. 7.
May I know the name of each?
Down.
Down.
Init.
Init.
2A.
2A.
Xstart.
Xstart.
Exchange.
Exchange.
Loading.
Loading.
And full.
Full. Very good. Like OSPF move from these states to form adjacency. BGP is also going to move from some states to form BGP relationship between two router, right? So we have 6 states in BGP. First one is idle. Idle. Second one is connect. Third one is open send. Open send. Fourth one is open confirm. Fifth one is idle, connect, open send, open confirm, and then last one is 5 states are there. Establish. 5 states. One is missing. Sorry, here active is there. No? Active. Init, connect, active, open send, open confirm, and established. Okay, guys. One second. CCI Enterprise, CCI BGP. BGP. Yes, here also you are able to see all state idle, connect, active, open send, open confirm, and establish. See guys, idle state is initial state. Idle state is initial state. In idle state, router will not listen TCP. As you know, whenever we configure BGP between two router, first routers is going to establish a TCP connection. After that, router will send any message of BGP. First message open message. After that, router will send open message. So idle state is initial state. In idle state, actually routers check their routing table to find route for their neighbor IP address. Let's say in this scenario, here on router number 1 I have one loopback 1.1.1.1, and on router number 2 also I have one loopback 2.2.2. I want to form BGP neighborship between 1.1.1 and 2.2.2. So first requirement is what? 1.1.1 should be reachable with 2.2.2, right? Right, guys? So let's say
Yes.
1.1.1 and 2.2.2 are not reachable with each other, and I have configured BGP. On router number 1 I have defined neighbor 2.2.2 remote as, let's say, 100. Then what will happen? Neighborship will be still in idle state because route is not available for neighbor IP address. Config T interface fast ethernet 0/0 IP address 12.1.1.1 255.255.255.0. Exit interface loopback 1 IP address 1.1.1 255.255.255. Let's say on router number 2 interface fast ethernet 0/0 say no set IP address 12.1.1.2 255.255.255.0. Exit interface loopback 1 IP address 2.2.2.2 255.255.255. Done. See, on router number 1 I am going to configure BGP. Router BGP AS number, let's say 100, and say neighbor 2.2.2. Remote AS is 100, right? And so IP BGP summary. Neighborship state is idle. Neighborship state is idle. Is router 1 sending SYN message to 2.2.2 to their neighbor? No. Why? Because router 1 don't have route available for neighbor IP address. So IP route. There is no any route available for 2.2.2. Okay, so IP route. And so IP BGP summary. So neighborship state is idle. Idle means initial state. Here router will not send any TCP message, right? Just router is searching their routing table to find route for neighbor IP address. If route is available, if route is available in the routing table, then state will move to connect state. Okay. If route is available, see in idle state, router search routing table for neighbor IP address, route for neighbor IP address. If it does not have route for neighbor IP address, then state will be in idle state. Then state will be remain in idle. Another reason for BGP idle state can be when we manually shut down the interface. When we manually shut down the interface, then also state will be idle. On router number 2 also I am going to configure BGP. Router BGP S number 100, and let's say neighbor 1.1.1 remote AS 100, right? IP route 1.1.1 255.255.255.255, and exit interface is, let's say, fast ethernet 0/0. Now route is there on router number 2. Let me configure one static route on router number 1 also. IP route 2.2.2.2 255.255.255.255, and exit interface is fast ethernet 0/0. Now BGP neighborship will come up. So TCP brief. What happened? Correct. So run. Neighbor 2.2 remote, yes, okay. And so IP route is available for 2.2.2 fast ethernet 0/0. So IP route is available for 1.1.1 on fast ethernet 0/0. And so run section BGP router BGP 100 neighbor 1.1.1 ping 1.1.1 source 2.2.2. Yeah, ping is working. So IP BGP summary. Neighbor is still idle. Clear IP BGP star no router BGP 100, no router BGP 100, router BGP 100, neighbor 1.1.1, remote AS 100, router BGP 100, neighbor 2.2.2, remote AS 100. So IP BGP summary.
Do we need to give update source?
Yeah, update source loopback one. Correct. Router BGP is number 100, neighbor 2.2.2, update source loopback 1, and neighbor 1.1.1, update source loopback 1. Now you can see we have neighborship, but if I will manually shut down the interface fast ethernet 0/0 shut down, again neighborship state will move in idle. Neighborship state is idle. Or the third scenario when you will see idle state is when you will manually shut down the neighbor. Admin shutdown, say no shut to this interface. So IP BGP summary, debug IP BGP, okay, and all. We have BGP neighborship. If I will manually shut down the neighbor, router BGP 100 and say neighbor 2.2.2 shut down. In this scenario also you will see neighbors neighbor state is idle. So IP BGP summary, neighbor is idle. So in three scenario you will see idle state. Idle is like down state in OSPF. Initial state when we define neighbor command in router BGP, then first of all interface will come in idle state. In idle state mainly router search routes for neighbor IP address. Okay, if router will find any route for neighbor IP address, state will move to connect. State will move to connect, and in connect state router is going to send what? SYN message. Router is going to send SYN message in connect state. Okay, if router finds a route for neighbor IP address, BGP peer move to connect state from idle state, and it will initiate a TCP connection. It will initiate a TCP connection. Router BGP is number 100, neighbor 2.2.2 shutdown, say no to this command. So IP BGP summary. Again we have neighborship. So in connect state R1 will send what? SYN message. SYN message on which port number? 179. And guys,
Ji, can you make
yes,
sure that recording is on?
yes, recording is on.
Okay, thank you.
Okay. If router is able to establish TCP connection, if router 1 is able to form TCP connection with their neighbor, then state will move to open send directly. Then state will move to open send directly. And let's say because of any reason router 1 is not able to form TCP connection, let's say port number 179 is blocked on router number 2, or because of any reason router 1 is not able to form TCP connection between R1 and R2, then state will move to active state, and in active state again router will try to form TCP connection. Getting my point? See, after idle state, will move in connect. In connect, router will try to form TCP connection. If TCP connection will form, then neighborship state will move in open state. If TCP connection will failed, then neighborship state will move in active state. And in active state, again router will retry to form TCP connection. Okay, let me do one thing. On router number 2, let's say I'm going to disable BGP. Say no router BGP yes number 100. And on router number 1 also I have, okay, no router BGP yes number 100. And on router number 1 now I am going to configure BGP. Router BGP yes number 100 and say neighbor not 2.2.2, let's say 12.1.1.2, and remote AS is 100. So this time this router is trying to form TCP connection. If you will capture this link, so you will see router 1 is sending SYN message, but router 2 will send reset message because port number 179 is disabled here. Getting my point? See, 12.1 is sending SYN message and 12.2 is sending reset message. That means router 1 is not able to form TCP connection in connect state. So state will move to active, or maybe from active to idle. If TCP connection will form, then state will move directly to open sent state. And in open sent state, router will send what? Open message. Then when router 2 will receive open message, it will verify parameters like open message carry version, it carry what AS number, like what AS number you have defined with neighbor. Remote AS is 100, so remote AS should be 100 in the open message. So if everything is fine, right, open message is verified, then router 2 will send what? Keep alive message, acknowledgement with the help of keep alive message. So once router 1 will receive keep alive message, state will move to open confirm. That open message is confirmed. First router have sent open message and now router is saying open confirmed, means open message is confirmed by my peer neighbor, and then state will move to established, and here router is going to send what? Update message, actual update message. Okay, so if you will debug, see router 1 is retrying to form TCP connection again and again. Right, and on router number 1, show TCP brief, you can see TCP table, right, and debug IP BGP, and now I am going to enable BGP on router number 2. See, state from idle to active, state is moving from idle to active. So actually in connect state, router will try to form TCP connection. If router is not able to form TCP connection, then state will again move to active, and then active to again idle. Fine. On router number 2, debug IP BGP, and let me configure BGP here also. Router BGP AS number 100 and say neighbor 12.1.1.1, remote AS is 100. And see here now messages. State neighbor adjacency up, and before that you can see open edge capability, route refresh message. Neighborship state move from active to open send. Earlier neighbor was in active state, Once TCP connection has formed, neighborship state move to open state. In open state, it will send open message. See, sending open message. Version 4, autonomous system number, this one, hold on time, this one, right? And after that, here somewhere we can see conform state also, open conform state. Receive open message and neighborship state. Here somewhere we can see neighborship state is moving from open to open send to open conform. Open conform to established and open send to open conform. Clear, guys? In capturing also, you can see earlier router 1 were sending a SYN message, and here router 2 have sent what? Acknowledgement of SYN message. Then router have sent first open message, router 2 have also sent their open message, both router have sent keep alive message. So when router will send open message, state will be open send. When router will receive keep alive message, acknowledgement, state will move in open conform, and after that state will move in, then router will send update message, and after update message state will move to establish. Now on router number 1 you can see we have TCP connection, so TCP brief, right? Clear, guys?
What are the types of messages sent during the establishment of the neighborship?
Update message, and if there is any error, let's say on router number 2, we have defined wrong neighbor remote AS. So router 2 will send what? Notification message. As I told you that whenever error will occur in BGP router will inform to their neighbor with the help of notification message. So here these upper three states are for TCP connection, and lower 3 states are for BGP messages.
Here, open message is sent, keep alive message is sent, and
after that update message is sent.
okay.
Open keep alive, update and notification, right?
A notification is only in case of error. Let's say because of some reason router 2 want to break the neighborship with router number 1. So in OSPF or in IGP protocol, directly router were breaking the neighborship, but in BGP first router will inform to their neighbor with the help of notification message, brother, I am going to break neighborship with you because of this reason. Here we are not able to see any notification message. Why? Because there is no any error. Let's say, see, routers are sending what? Keep alive message. Keep alive message. After every 60 seconds, router 1 is sending keep alive message, right? Keep alive message. Let's say because of congestion, router 2 have not received keep alive message. So it will wait for hold on time. Miss 180 second is hold on time. After 180 second, router 2 will send one notification message to router 1. Brother, I am not receiving your keep alive message, so I am going to break the neighborship with you. Getting my point?
Yes.
1 minute. So this is all about BGP states. We have 6 states in BGP, and here in book also you can see, in idle state router will not listen for TCP, it will not initiate TCP, right? In connect state router start listening TCP and it will initiate TCP connection as well. In active state router can listen TCP or it can initiate TCP message. In open send message it can send open message. In open confirm message it can send as well as receive open message. And in last stabilized state it can listen TCP, it can initiate TCP, it can send open message, it can receive open message, and it can neighbor is up. Okay, these are messages. Notification used when BGP error occur. Update used to exchange routing information. Keep alive used to track neighbor and acknowledgement. Open used to form neighborship. Done. Okay, now next is route filtering. For route filtering, let me design one topology. I think I have one topology with BGP configuration. हाँ क्या हुआ? ठीक है दे दो चलो. Okay, so see guys, this is my topology. In this topology I think BGP is already running. Let me verify that first. R1 on each router we are running different autonomous system numbers. So IP BGP summary. So 12.2 is neighbor, router 4 is neighbor, router 2 and router 4 are neighbor of router 1. Let me access all router. Okay, so IP BGP. So IP BGP, inside the BGP table we don't have any prefixes, so run section BGP. So we are advertising these prefixes here. So IP BGP. Okay, wait for some time. Topology is getting updated. Yeah, now router have received all 20 prefix. Soon router 1 will receive 30 and 40 prefix also. It is receiving all 40 prefixes, all 30 prefixes and all 20 prefixes, and it is advertising 10 prefixes. Okay, now router 1 is receiving 20 prefixes from which neighbor? From router number 2. It is receiving 30 prefixes from which neighbor? From router number 4. Why it is not receiving from router number 2? It should receive from router 2 also. Yes, now you can see. So IP BGP. Okay, so IP BGP. Yes, so IP BGP. Done. Now guys, let's create some scenario here. First of all, see R1 BGP table, so IP BGP. Router 1 is getting 20 prefixes from router number 2 only. From router number 2 only. It is not getting 20 prefixes from router number 4. Reason is actually router 1 is advertising these prefixes to router number 4. On router number 4 you can see so IP BGP. Best path is via router number 1. 14.1.1.1. Best path is via router number 1. Via router number 3 it is only valid, not best. Okay, so let's say on router number 1 I want to filter 30 prefixes. I want to filter 30 prefixes. Now router 1 is learning all 30 prefixes from which neighbor? From router number 4. From router number 4. Yes, path is 300. So let's say I want to filter these all 30 prefixes from router number 4, or I want to filter 30 prefixes from both neighbor, from all neighbor, right? From a particular neighbor also we can filter these prefixes, and from both neighbor also we can filter prefixes, right? So filtering is same. First of all we have to match prefixes with the help of access control list or prefix list. So let me create one access control list here. IP access list standard, let's say number 10. Here let's say permit 30.1.1.1, deny 30.1.1.0, 0.0.255, 30.1.2, 30.1.3, 30.1.4, right? And now router BGP 100 distribute list, router BGP. Oh, I have created access control list on router number 4. So let's say on router number 4 I want to filter 30 prefixes. So router BGP is number 400 and then distribute list. Now you can call access control list number 10 and then in which direction you want to apply, in direction, right? And so IP BGP. Now you can see 30 prefixes are still there, so clear IP BGP star soft in, and now so IP BGP. So you can see 30 prefixes are filtered, 20 prefixes also filtered.
Now, allow permit command you haven't given, last.
Oh, IP access list standard 10 permit any clear IP BGP star soft in, so IP BGP. Done. Okay,
Yes, it's filtered. Yeah.
30 prefixes are filtered. Now I don't want to filter 30 prefixes, just I want to filter 30 prefixes from router number 3. I want to receive 30 prefixes from router number 1. Means what I want, that whenever user from these network want to communicate with user of this network, they should communicate via this path. So I want to filter prefixes from a particular neighbor. So what we can do, router BGP 400, and first of all say no distribute list number 10 direction in, and then I am going to say neighbor 34.1.1.3, which is IP address of router 3, and then I will call to distribute list. Distribute list number 10 direction in. Clear IP BGP star soft in. So IP BGP. Now this router is learning all 30 prefixes from router number 1. So 30 prefixes are filtered via router number 3. And guys, you know, in BGP we have a command like we can check how many prefixes this router is advertising to which neighbor, and how many prefixes this router have received from which neighbor. Like so, IP BGP neighbor, let's say 34.1.1.3, and received prefix, received route. So this command will show me all received prefix from this particular neighbor. So from this neighbor, okay, for that we need to run one more command here, router BGP AS number 400 and say neighbor 34.1.1.3 soft reconfiguration inbound, and now we can run this command. So see, from router number 3 I'm receiving these all prefix. From this neighbor I am receiving 12 number of prefixes. So these prefixes are not best only valid because we have already filtered these prefixes, right? Okay, and if you want to check that this router is advertising how many prefixes to router number 3, so IP BGP neighbor 34.1.1.3 advertise route. So see, router 4 is advertising 16 number of prefixes to this neighbor. Okay, first of all let me remove the filtering. Do so run section BGP router BGP AS number 400, say no to this command, right? And then no IP access list number standard 10, clear IP BGP star soft in. So IP BGP. Now again this router is getting 30 prefixes from both neighbor, from router 3 also and from router 4 also. Best is via which router? Best is via router number 3 on the basis of which attribute?
Next hop, next.
No, both next hop are reachable. Both next hop are reachable from router number 4.
I think yes.
Yes, yes path. On router number 1, so IP BGP. Router 1 is also learning 30 prefixes from 2 neighbor and best is via router number 2. Why?
Same yes only.
When router 2 is advertising, yes number is 200. When router 4 is advertising, yes number 400 and 300 are there. On R1,
I think see
it is
this time
not,
it's
yes,
this is
time,
R1, right? R1. This time I think it learned
yes
from that
number is same.
lower ID, lower network.
Lower neighbor router ID.
Yes.
That attribute check in case of IBGP, not in
Yeah.
case of eBGP.
Okay.
Then oldest path for
Yeah.
eBGP, oldest path. See, now best is via router number 2. But if this neighbor will goes down, if I will down this link, fast ethernet 0/0, and if I will up the link again, then best path will become via router number 4. So we can check it that router is really performing best path selection on the basis of all best path or not. Interface fast ethernet 0/0 says shutdown. I've done the interface. BGP neighborship has goes down, and let's say no shut again, and so IP BGP. Now you can see, wait, best via router number 4, and router 2 is also going to advertise these prefixes to router 1. You can see, but still best is via which router? Router 4, because of oldest path.
Okay.
Okay, now we can create any scenario which prefix you want to filter. Let's say on router number 1, on router number 1, okay, one more thing, on router 1 show IP BGP. For 30 prefix we have two path. And guys, if you want to perform load balancing here, right, if you want to perform load balancing, so BGP can perform load balancing if IGP cost to reach next hop, all attribute till IGP cost to reach next hop is same, then we can achieve load balancing. So in this scenario, till IGP cost to reach next hop, all attributes are same, so here we can achieve load balancing. Now router have installed only one path in their routing table, right? But let's say I want to achieve load balancing here for these prefixes. So what we can do, router BGP is number 100, and here we can configure maximum path 2, and so IP BGP. So IP route BGP. So IP BGP. Clear IP BGP star soft in. So IP BGP. Now it should perform load. Oh, router BGP 100 maximum path for, this is for eBGP na? For eBGP we have set to do so IP BGP it should perform load balancing. Now this is problem of GNS3. Then if it is not performing load balancing, it should perform load balancing. Now let me try on any other router. Router BGP is number 100, no maximum path 2. On router number 2, let's say, so IP BGP, we have two path for 30 network. For 40 network also we have two path. Okay, from both side we are getting two number of ES. Router BGP ES number 200, maximum path 2. So clear.
No, here this is iBGP, right?
eBGP.
Sorry,
On each router
eBGP.
we are yes.
eBGP. Then here we can perform that this one path.
Yes, we can perform path manipulation if all attribute till IGP cost to reach next hop are same. still it is not performing load balancing. Command is same, guys. To perform load balancing, here we can configure maximum path till 32, right? And if all attribute till IGP cost to reach next hop are same, then router will perform load balancing. Okay, let's say in this scenario, what I want, router 1 never need to communicate with this network. Let's say 30.1.4.1/24, 4.0/24 in this network. So I want to filter this particular network on router number 1. I want to filter this particular network on router number 1. I can filter it on router number 3 also, on router number 2 also, on router number 4 also, right? If I will apply filtering on router number 3, then router 2 will also not get this network, router 4 will also not get this network. So either I can filter this network on router number 2 or on router number 4 or on router number 1. If I will filter this prefix on router number 2 for this neighbor, then I will apply it on odd direction. If I will apply filtering on router number 1 from router number 2 or from router number 4, then I will apply it in direction. Or let's say,
I think we have to put that filter on that right router number 4 also. It will learn from this router number 4 also, right? That router 1.
For all neighbor I can filter now, for all both neighbor.
Yes, yes.
Or let's say router 1 want to receive this two upper prefix, this two upper prefix, and this two upper prefix only from router number 2, from this neighbor. From this neighbor, router 1 want to receive these 6 prefixes, not from router number 4. So this type of filtering can be achieved by route map. This type of filtering can be achieved by route map. See, on router number 1, I will create one access list first, IP access list, standard, let's say number 10, permit 20.1.1.0.0.255, then permit 20.1.2.0, then permit 30.1.2.0 and 30.1.1.0 and 40.1.1.0 and 40.1.2.0. Only these prefixes. Now what I can do, router BGP AS number 100 neighbor 12.1.1.2 use route map. Sorry, I have not created route map now. Route map CCIE permit or deny. Deny.
Deny means okay. Okay.
One minute.
We are allowing, right, for this 20. That
we are denying, na?
Deny. Okay.
Okay, we are allowing, yes. Here it should be permit.
Yes. So that's fine.
Match IP address from list number 10. And now router BGP S number 100, say neighbor 12.1.1.2 route map.
CCI.
CCI direction in. Now router 1 will receive only those prefixes from this neighbor which will match in route map. And in route map, which prefixes will match? These prefixes only. Right. So IP BGP, and before that clear IP BGP star soft in. So IP BGP. So IP BGP, and what we can say, neighbor 12.1.1.2 received route.
Actually, what it will do, this soft reconfiguration means?
This is, soft configuration is like I want to check how many prefixes or how many network I have received from a particular neighbor, or how many prefixes I have advertising to a particular neighbor. So this soft type output, if you want to check, you have to enable it. Like you can see, after running that command, I am able to check how many prefixes I have received from this neighbor. Earlier I was not able to run this command
Yes, yes.
because we have enabled soft configuration, soft reconfiguration in bond for this neighbor. Okay, and now you can see I'm getting only these two prefix from R2. Why I'm not getting up these 30 prefix and 40 prefix? I think then router 2, so IPBGP router 2 is learning 30 prefixes from which neighbor? From router number 3. So router 2 should advertise 30 prefix as well to router number 1. Wait. These are not best. So IP access list, here we have permitted this network also. So IP BGP actually 30 prefixes is best via router number 4. So let me do one thing. First I am going to down neighborship between router 1 and router 4 just to see the clear output. Router BGP 100 and say neighbor 14.1.1.4 shutdown. Clear IP BGP star soft in, and so IP BGP, so IP BGP neighbor 12.1.1.2 received route. Now you can see it is receiving these two upper prefix, and these two upper prefix only from router number 2. So IP route BGP. In the routing table also we are able to see these two upper prefixes, these two upper prefixes, and these two upper prefixes. Getting my point? So in real time, sometime we configure filtering like this. How many prefixes I want to receive from this neighbor, how many prefixes I want to receive from this prefixes, and let's say now I want to receive lower two prefixes like these two prefix, and these two prefix from R4, from R4. So what I will do, I need to create one access control list on router number 1, router BGP 100 neighbor 14.1.1.4 shutdown. Say no to this command first, and let me know IP access list standard, let's say 20, and here I am going to say permit 40.1.3.0 0.0.255 40.1.4.0 20.1.4.0 and 1.3.0 and 30 dot 1.3.0 and 30.1.4.0, right? Then route map, name of route map is, let's say, CCIE 1, or what we can say, receive route from R4, permit, match IP address from list number 20, and router BGP is number 100, neighbor 14.1.1.4, use route map, this one. Let me copy the name of route map, and then direction in, clear IP BGP star soft in, and show IP BGP. You can see router 1 is learning upper two prefixes, where it is, upper two prefixes from router 2 and lower two prefix from router 4. For 30 prefixes also, upper two prefix from router 2, lower two prefix from router 4. For 40 prefixes also, upper two prefixes are reachable via router number 2 and lower two prefixes are reachable via router number 4. Getting my point, guys?
Yes, yes, yes.
What I want, router 1 should not advertise any prefixes to router number 2. That also I can achieve. I want router 1 should advertise upper two prefixes to router number 2 and lower two prefixes to router number 4. That also I can achieve. Getting my point? Tell me the scenario I will configure route filtering. Which prefix you want to filter?
No problem here, we understood.
Right? So now you guys can perform route filtering also in BGP. Yes?
Can you explain distribution list?
Distribute list.
Yes.
What I will explain in
No,
distribute
the
list?
syntax, how it is. We know access list, prefix list, route map. I don't know how to use that distribution list.
Distribute list, you know, like you can apply access control list on interfaces here. Like this, you can apply filtering in routing protocol with the help of distribute list.
Mhm.
If you want to filter some prefixes on interfaces, you can apply access control list on interface. But if you want to apply access control list in routing protocol, I don't want to filter prefixes on interfaces. For that we have distribute list, and distribute list work with all routing protocol, with IGP also and with EGP also.
Is there any order of preference for access list, prefix list, distribute list?
Order of
Preference, which is more
no, it totally depends on our requirement. When I want to filter prefixes on the basis of prefix length, then I should use what? Prefix list. When I want to match prefixes, I should use access control list. When I want to match other parameters like tag number, like local preference, yes, then you should use route map. If you want to match metric, if you want to perform filtering on the basis of metric, like any prefix with metric, let's say 3, and if I don't want to receive any prefix with metric 32768, so I can filter prefixes with the help of metric, but I cannot match metric in access control list or prefix list. Then I have to use what? Route map. So all are in use. Access control list also is in use. Prefix list is also in use. Route map is also in use. It's totally depends on our requirement, on the basis of what parameter I want to filter prefixes.
We can use communities also here, right? No advertise, no export.
Yes, we can.
Instead
Of
of
course.
using
Community is actually used to, for tagging. For tagging with these prefixes, I want to add tag. Like in EIGRP, we understood with the help of tag, we perform path manipulation, we performed route filtering. So in BZP, if you want to add tag, you need to use community. And after that, with the help of tag, we can again perform path manipulation or route filtering. See, I have one scenario here, I think. Let me check. Scenario is there or not. I've just saved that scenario. This one. I think I have deleted that topology. There was some misconfiguration, and I was troubleshooting that network. There was problem with route filtering. Things topology is no. I have deleted the topology. Okay, leave. Route filtering was there only.
G, can you please configure this distribution list here on this scenario?
Yeah, let's say on router number 3, I want to filter 10.1.1.0/24 network. So IP BGP. Now router 3 is learning this network from both neighbor, and let's say I want to filter it, right? So what I can do, I can create one access list. Let's say IP access list standard number 10, then deny 10.1.1.0.0.255, and go to router BGP AS number 300, say distribute list access list number 10, and in which direction you want to apply, in direction. That's it. Clear. IP BGP star soft in. So IP BGP IP access list standard 10 permit any. For REST traffic, I have defined permit statement. So 10.1.1.0 is filtered. So run section BGP. This is command, brother.
here we can use prefix lists also instead
Yes,
of
we can use prefix list also. Let's say with the help of prefix list, I want to filter 40 prefixes. So IP BGP. 40 prefixes are there? Yes. So what I can do, I can create one prefix list, IP prefix list, CCIE deny 40.1.0.0/16 greater than equal to 24, less than equal to 24, and IP prefix list CCIE permit any for any 0.0.0/0 less than equal to 32. Router BGP S number 300 distribute list prefix list name CCIE direction in. Access list filtering exists over here, so I can apply it with neighbor, or I can remove that command. Say no distribute list number 10 direction in, and then we can run this command and clear IP BGP star soft in. So IP BGP, you can see 40 prefixes are filtered. Hmm? router BGP 300. Fine. Now can I move to switching module? Okay, so let's complete NAT and VPN first. After that, I will start switching module. Okay. So let me design one topology here for netting. Okay, this is my private network. This is my private network. This is public network, ISP network. Okay, on ISP, let's say we have one loopback 8.8.8.8, and inside my LAN we are using this network 192.168.10.0/24. Let's say, right? First of all, try to understand how these users are going to ping 8.8.8. So let's say this user IP address is 10.1 and this user IP address is 10.2. Gateway is, let's say, 10.100, 10.100. So whatever IP addresses we will use inside my network, that is private IP address, and here we are going to use public IP address. Let's say ISP have provided me one IP address 15.1.1.1, right? So this is my public IP address, and ISP side public IP address is 15.1.1.2. Let's say this is my topology. So this is inside zone, this is outside zone. You can see this is private network, this is public network, right? So by default, communication between private to public is not possible. Why private to public communication is not possible? See guys, when 10.1.1.1 want to ping 8.8.8, source IP address is going to be 10.1.1.1 and destination IP address is going to be 8.8.8. This PC will forward this packet to their default gateway. The default gateway will check their routing table R1. On R1, on your edge router, you will configure one default route towards ISP, because ISP is connected with million of networks, so it is not possible to configure route. So on edge router, we will configure one default route towards ISP. So R1 will use that default route to forward packet towards ISP. Router 1 will forward packet to ISP. ISP will check destination is 8.8.8, right? ISP will generate what? A reply. Or if there is one server who is using IP address 8.8.8, ISP will forward the packet to that server. Server will generate reply. In the reply, source IP address is going to be 8.8.8 and destination IP address is going to be what? 10.1.1.1. Now ISP router don't have any route available for 10 network. By the way, private IP address are not allowed on ISP, right? So ISP will drop the traffic. So in this scenario, what we need to do, we need to perform translation on router number 1. On router number 1, we need to perform translation. Whenever LAN user want to forward traffic outside public network, this router will translate source IP address, right? Let's say this router have translated source IP address. Here source IP address is 10.1.1.1, destination IP is 8.8.8.8. when user will generate the traffic. When router will forward the traffic to ISP, router will change source IP address. Let's say router have set public IP address what? 15.1.1.1. Router 1 have set this IP address as a public IP, as a source IP address, and then router will forward traffic to ISP. So this time ISP will generate reply for 15.1.1.1 and route is available for 15.1.1, right? So ISP can forward traffic to this router. Again, when router will receive traffic from ISP, router 1 will translate this 15.1.1.1 into 10.1.1.1. See, when ISP will generate reply, source IP will be 8.8.8 and destination IP will be 15.1.1.1. When router will receive this packet, router is again going to change destination IP address. Destination IP address will be here 10.1.1.1 again, and then router 1 will forward packet to this user. Clear? So why we come up with NAT? To make communication possible between private and public network. Actually, NAT is required for multiple reasons. Most common reason is translation. Translation of private IP address into public IP address. After that, we have multiple types of NAT: static NAT, dynamic NAT, and PAT. We have 3 types of NAT. You have to understand the scenario in which scenario I need to use a static NAT. See, we are not using nowadays dynamic NAT. We are using a static NAT and PAT. Only these two types of netting are used nowadays, are in use nowadays. Then we have some zone, means some type of area in netting. First one is inside local zone, inside local, inside global, then outside local, and outside global. We have 4 zone. Inside local means my private network. Inside global means my public network, my public IP address. And let's say this ISP is connected with Google. Google will have also one switch and they have lots of server, right? And Google network is also connected with ISP through one router like this. So if I want to access Google server from my inside network, so Google private network is outside local for me, and Google public network is outside global for me. Outside global for me means this network is outside global, this is outside local, this is inside local, and this is inside global. Inside local means the IP address of devices inside the network. This address will be translated to inside global address. Inside global address. This address will be translated into this public IP address. Configuration is, guys, very easy. On ISP router, I will configure only IP addresses. On ISP router, I will configure only IP address interface fast Ethernet, serial 2/0, serial 2/0, say no set, and IP address 15.1.1.2, 255.255.255.0, exit interface loopback 1, IP address 8.8.8, 255.255.255.255. That's it. Now let me close the console of ISP. On R1, interface fast Ethernet 0/0, say no set, and IP address 10.1.1.100, 255.255.255.0, exit interface serial 2/0, say no set, and IP address 15.1.1.1, 255.255.255.0. On edge router, first of all, you need to define one default route towards ISP. So IP route 0.0.0.0.0, exit interface is serial 2/0, and next hop IP address is 15.1.1.2. Now can I ping 8.8.8 from here? Will ping work?
Yes.
Yes, because source IP address is going to be 15.1.1.1 public IP address. So I'm able to ping. But can I ping 8.8.8 from my LAN interface from source fast Ethernet 0/0? No, it will not work. Why ping is not working this time? Because this time in packet source IP address is private, right? And ISP are not able to, ISP is not able to generate reply message, not able to forward reply message. But if I am pinging, see, ISP router is actually receiving ICMP traffic. Debug IP ICMP. See, it is receiving ICMP traffic. It is generating reply message also. Source is 8.8.8, destination is 10.1.1.100, but route is not available on ISP router. Because of that, ISP router is discarding the traffic. So here on R1, what we can do, we can configure NAT. See, To configure NAT, first of all, you have to define inside interface and outside interface. Which interface are inside and which interface are outside. So interface serial 2/0, IP NAT outside. This interface is outside. After the interface fast Ethernet 0/0, IP NAT inside. This interface is inside. Done. Then access list number 10, permit 10.1.1.0.255 and IP NAT. I have created access control list to match the traffic. Means to tell to router, you need to translate which private IP address into public IP address. Which private IP address into public IP address. So now we are running IP NAT inside, and source should be match from access list number 10. So source is going to be list 10, and destination means what should be the public IP address. Router 1 will translate source IP address with what public IP address. So public IP address which is running on interface serial 2/0, let's say, right? And now ping 8.8.8 and source fast Ethernet 0/0. See, ping is working. If you will capture the link, again I am pinging. See, source IP address is 15.1 in packet, node 10.100, and so IP NAT translation. So you can see R1 have translated 10.1.1.100 into 15.1.1.1.
Can you please explain this NAT translation table once again? I'm getting confused. Because and outside we are exiting via 15.2, right? I mean the interface serial 2/0.
Yes.
But both sides is showing the same IP address. I mean 8.8 and 8.8. Inside, I mean outside local and outside global.
Yeah, because I have just created one loopback on ISP. Let's say ISP is connected with one another router, and that router is connected with one LAN. Okay, like this. And let's say here also we are using one private network 20.1.1.0/24. So in this scenario, if you will ping 20.1 from 10.1, you will see outside local is going to be 20.1 and outside global is going to be public IP address which is running over here, right? This time I am pinging 8.8.8 which is directly connected with ISP. So outside local and outside global is same. And this is, guys, actually this is PAT, port address translation.
What is this one, :3 and :4?
:3.
If you see that that inside global also :1024, and inside local also :3 :4. After that,
port number. This is port number. Actually, I told you, router is performing PAT this time,
yes.
port address translation.
Okay.
You know, there are three types of NAT. A static NAT. First, a static NAT is one-to-one translation. Means one private IP address will be translated into one public IP address. Then we have dynamic NAT. In dynamic NAT, we can create a pool of public IP addresses. Let's say in pool, I have defined 5 number of public IP addresses. So router will translate private IP address into public IP address from that pool. Okay. And in PAT, port address translation, router will translate all private IP address into single public IP address with the help of port number. right? So let's say here we have two users. PC1 is using 10.1 IP address and PC2 is using 10.2 IP address. So 10.1 and 10.2 both IP address will be translated into single public IP address, into this public IP address 15.1.1.1. Then how router 1 will came to know that which private IP address is translated into which public IP address. Means when reply will come from ISP side, let's say both PC have sent one request to ISP to 8.8.8, right? So router 1 have translated 10.1.1.1 into 15.1.1.1. It have translated 1.1.2 into 15.1.1.2, sorry, 1 into same public IP address. So when reply will come, how router 1 will came to know that reply is coming for 10.1.1.1 or 10.1.1.2. So for that, router 1 will assign one port number while translation. It will assign one port number. Let's say here it have assigned one port number, source port P1 and destination port P2. Here it have assigned source port A1, destination port A2. So in the reply message, if source port is P2 and destination port is P1, that means I need to translate public IP address into this private IP address. If in the reply source port is A1 and destination port is A2, router 1 will came to know that I need to translate this public IP address into this private IP address, right? So actually router is performing translation on the basis of port number. So this is port number. Let me do one thing. Here on this PC I am going to assign IP 10.1.1.1/24 and gateway is 10.1.1.100. On PC2 IP 10.1.1.2/24 and 10.1.1.100. Now let me send ICMP packet from PC1. See, PC1 is able to ping 8.8.8 and ping 8.8.8. PC2 is also able to ping 8.8.8, and now if you will check translation table, you can see 10.1.1.1 is translated into same public IP address 15.1.1.1, and 10.1.1.2 is also translated into same public IP address, but both have different port number. So router is assigning source port and destination port while translating. In next class, I will make you understand the scenario where you need to configure a static NAT, where you need to configure PAT, or we will configure dynamic NAT also. Okay, this is basic about NAT. After that,
Why a lot of port numbers are there?
Sorry?
For 10.1.1 and 10.1.2.
For 10.1.1.1,
24, 1025, 26, 27, 28. Till 28, it's assigned for that 10.1.1.
This is source port number.
Okay.
This is destination port number for reply packet. And now guys, let's say ISP is, I have one another side here, R2. So I want to make communication between these two private network over public network. So by default, as I told you, communication between private to public is not possible. For that we come up with NATing, right? In the same way, private to private communication over public network is not possible. Let's say here we are using this network 192.168.20.0/24. So if you want to make communication between private to private, you have to configure VPN. So to make communication possible between private to private over public, we come up with VPN. So here we will configure what? VPN. Right? Actually here virtually we will create one link between R1 and R2. On that link we can run routing protocol also, we can run a static route also. Like through this tunnel we can share this network to router number 1, and I can share this network to router number 2 through this tunnel. Okay. NAT and VPN. Tomorrow we will cover these two topics. After that we will start switching. That's all for today, guys.